All right, and welcome back. So today we are going to be going through section 7.6, which is all about how to choose a factoring method. So far, we've talked about different ways of factoring. We've talked about factoring by the greatest common factor, the GCF. We've talked about how to factor when our a value is 1, how to factor a quadratic when our a value is not 1, and we've talked about some special products. So today we're just going to be going through a general review on how to factor and some of the methods that we want to use when we're presented a certain situation. So please have out your guided notes and let's begin. So we're going to use the following table to help us choose a factoring method. Now, this table does go a little bit differently than the way that we are going to be talking in class, but it's still a good general understanding of what we're trying to aim for. Within these guided notes, they're not going to mention the grouping method of factoring when it comes to a trinomial, but that's the way that I do it and the way that I have been showing you, because that's the way I feel is best for y'all and what is most comfortable in the long run. So please just know that some of the terminology is going to be a little bit different than what we have been going with, but the overall idea is still rock solid. So first, we're going to factor out the greatest common factor if possible. We always want to pull out that greatest common factor because it's going to be making our trinomial, our quadratic, a lot easier to work with. Then, if it's a binomial, if it has only 2 terms, we're going to check for a difference of squares. If it is a difference of squares, then we're going to use a plus b times a minus b. If it is not a difference of squares and there's no other GCF, it cannot be factored. Now, once we factor out the greatest common factor, and then we see it's a trinomial, then we're first going to check for a perfect square trinomial. If it is a perfect square trinomial, then we're going to factor it just like we had before using a plus b squared or a minus b squared. If it is not a perfect square trinomial, we're then going to factor just how we normally would. In these guided notes, it says if a is 1, check for factors of c that add up to b, and if a is not 1, check for the inner plus outer factors of a and c that sum to b. Again, we're just going to factor this trinomial if possible. You can use whichever method you like. Again, I teach by grouping because I feel it's the most straightforward method when it comes to any situation. But again, that's just me. You might have something that you like to do differently. By all means, go for it. And if there are 4 or more terms, we're going to try to factor by the grouping method, right? So we're going to be using this table to help us identify certain situations that are going to help us factor. So let's go through a couple of those situations. Let's explain how to choose a factoring method for x squared minus x minus 30. Then we're going to state the method, and we're going to be going through the ins and outs of it. So the first thing that we notice is that there is no greatest common factor. So we cannot factor out a greatest common factor. So we're still left with x squared minus x minus 30. We see it's a trinomial. That means we have 3 terms. This is actually what's called a quadratic expression. We have x squared minus x minus 30. So we're going to be using either some which way or out a trinomial setup. So it could be a difference of perfect squares. I'm sorry, not a difference of perfect squares. Apologize for that. A perfect square trinomial. Either a plus b squared or an a minus b squared. If it's not that, then we're just going to factor however we do. The terms a and b, those are not perfect squares. So this is not a perfect square trinomial. So we're just going to factor just like normal. So we're just going to factor it. Then once we eventually do factor it, we're going to get, let's do it off the top of my head, we're going to get x minus 6 and x plus 5. So we should end up with x minus 6 and x plus 5. Let me just double check that real quick. Cool, sweet. So that would be our answer if we were to factor this out. Let's talk about another example. Let's talk about how to choose a method with 2x squared minus 50. And then we're going to be stating the method. And then let's see if we can actually solve it or factor it. Well, we can factor out that greatest common factor. The greatest common factor is 2. So we pull out that 2, we're going to be left with x squared minus 25. But notice that the 2 is going to be coming along for the ride the entire time. It's part of this expression. There is no other side of the equal sign to divide out by it. It's part of our expression. We have x squared minus 25. That's a binomial, which means we can now look to see if it's a difference of perfect squares. If it's not a difference of perfect squares, it cannot be factored. Well, a and b are perfect squares. X squared and 25. Those are perfect squares, which means it is a difference of squares. So we factored out that 2, and then we're going to be using the setup of different squares. When we do have our answer, it would be 2 times x plus 5, x minus 5. And again, that 2 is coming along for the ride. It's still part of that overall expression. So if we were to use the multiplying process, we would still have to send that factor of 2 back into everything. Awesome. With this in mind, please work on problems 1 through 3 on the guided notes and resume when you're ready to move forward. All right, so it's often necessary to use more than one factoring method to factor a polynomial completely. Keyword here, completely. Whenever we simplify things before, we simplify completely. It's the same concept. We're going to be factoring completely. So let's go and factor 5x squared minus 5x minus 60. Again, completely. Well, we're going to see if we can factor out the greatest common factor, and we definitely can. We can factor out 5. 5 is going to be our greatest common factor. So we end up with 5 times x squared minus x minus 12. And now you're going to just factor x squared minus x minus 12, again, doing whatever method you want to. We're going to end up, again, this goes through the factors of it in the sum, and we're going to end up with 5 times x plus 3, x minus 4. But again, that 5 is carrying along. We need to include that 5 on the outside because it's still part of the overall expression. We didn't get rid of it. We just pulled it out a little bit. And then we can always check our answers to make sure that what we got is the correct answer, because we should we should end where we started. Right? If we were to do the multiplying process, we should get back to where we started because we aren't changing anything. We're just changing the way it looks. That's all we're doing. The value is still the same. We're just changing the way it looks. Again, it's often necessary to use more than one method, right? So let's talk about 16x squared minus 36, and we're going to factor that completely. So we're going to factor out the greatest common factor between 16x squared and 36. We're going to be able to factor out 4. So that 4 is going to be coming along for the entire ride. Now we have 4x squared minus 9. One of the things that I notice is that it's a binomial, which means it might be a difference of perfect squares. And that's the only way we can factor a binomial. It's a difference of perfect squares. So we have to check that now. So it is a difference of perfect squares. 4x squared, the square root of that is 2x, and then 9, the square root of that is 3. So we can use it as a plus b, a minus b. So we end up with 2x plus 3 and 2x minus 3. But again, we have to write it as a complete factorization. So that 4, again, comes along for the ride. And we can always check our work. We can do the multiplication process, and then we see how it goes. Awesome job with this one, kiddos. The general understanding of this is that we are just going to have to factor completely. We sometimes are going to have to use 2 different methods, mainly pulling out a greatest common factor and seeing where we go from there. But with that, please work on problems 4 through 9 on the guided notes. Y'all are doing super duper well. Keep up the great work. Keep making yourself proud. Let me know if you have any questions, and I'll talk to you soon.